Electricity class 2, the arrangement of resistor in parallel and in series. Before we calculate, in our previous video we only look at circuits consisting of either resistor in parallel or in series, but here we have it to be at a joint parallel and serial circuit resistor. So look at what we are going to do. First of all, let's complete the circuit so that we put a wire that is going to go from here and the wire is going to come back to this place. Remember, we need to put a source of current, which may be a battery, so we have to put that little sign over here representing the battery. We may also have the voltage to be at the battery side, so that this resistor, let me just put the variable, which may be have this one as 1 ohm, that is resistor. We have this one to be 2 ohm, we have this one to be 3 ohm, we also have this one to be 1 ohms. All right, now if you ask to calculate the total resistor that you have in this particular circuit, what you need to do first of all is calculate the total resistor you have in parallel, then you add it to the one you have in series and calculate the total resistor in series. That becomes the total resistor you have at this circuit. So let's go. 1 over R total, that is the formula for resistors in parallel, equals to 1 over R1 plus 1 over R2 to how many resistors you have. So that 1 over R total, 1 over R total equals 1 over R1. I could take it to be 3 or 2. Let me take it to be 2 plus 1 over R2 is 3. Now, the LCM of 1 over R total equals the LCM of 2 and 3, I will take it as 6. So that 6 divided by 2 is going to give me 3. 3 multiplied by 1 is 3. 6 divided by 3 is going to give me 2. 2 multiplied by 1 is what? 2. That is plus. And this is now equals 1 over R total equals to 3 plus 2 is 5 over 6. All right, so that the R total, I'm going to cross and multiply, so that I'm going to have 5 R total equals 1 multiplied by 6 is 6 divided by 5 divided by 5. This cancels this, so that R total is going to give us 6 over 5, and this is my answer of resistor I have in parallel. Now look at what is going to happen at this circuit. I'm going to now see that this circuit is going to look something of this form. Now this one is still what I have as the 1 ohms, and now this one that we are in parallel, which I've now summarized to be a total resistor and got it to be 6 over 5, we now join those in series to become at this point, so I have it as 6 over 5 ohms, and this one also remains as 1 ohm. So this is what the circuit is going to look like, and we still have it to be in this form. But meanwhile, while you're studying, you don't need to just come and clean the question you have and put it in this form. Just know that you now have it to attach to the ones in series. So what we need to do now is to calculate the total resistor in series. Total resistor in series now becomes the resistor that is total on this circuit. So that now the total resistor you have in series given by R1 plus R2 plus R3 to how many resistors you have. So that the R total now I have in series is 1 plus 6 over 5 plus 1. All right, so at this juncture, we dash here 1, dash here 1, so that the R total equals the LCM of 1, 5, and 1 is nothing but 5. 5 divided by 1 is 5. 5 multiplied by 1 is 5. 5 divided by 5 is 1. 1 multiplied by 6 is plus 6. 5 divided by 1 is 5. 5 multiplied by 1 is 5. All right, so now we go it to be equals to 5 plus 6 is going to give us 11. 11 plus 5, sorry, 5 plus 6, 11. 11 plus 5 going to give us 16 over 5. At this juncture, there is nothing can divide. So this is what we have as our what? Our total. All right. Now, if the total resistor in this circuit is 16 all over 5, that is total resistance, that is the answer. You also leave it in a ohms. Now let's assume that we are giving the current at this circuit, the current passing through this circuit. Remember I said that the current is only represented at one particular place. You might put it here, you might also wish to put it here, you might also wish to make it to be here, or you might also wish to make it to be here. But anywhere you want to put it, make sure that it appears only a single place. But however, there is a case whereby we need to find the current passing through this individual resistor that I have here. We haven't reached that yet. So for now, let's put the current to be here. And let's assume that this current is 5 ampere, measured in ampere. And then the question says, in this circuit, find the voltage of the circuit below. Now you are giving all this resistor, you are giving the current, and you're giving the voltage. Remember that voltage is equals to current multiplied by resistor. Now if I was given all of this to find the voltage, notice that voltage will now become equals to, what is the current? The current was given to be 5, and now this is going to be multiplied by the resistor. Now, the aim of knowing how to calculate the resistor and resistor in total is so that if I have to use the resistor here, I'm not going to put 1 as the only resistor, I'm not going to put 2 as the resistor, I'm not going to put 3 as the resistor. I need to find the total resistor I have in this circuit. And because of that, I need to now calculate the one in parallel first of all and calculate the one in series, which is what we have just done. And we have gotten it to be what? 16 over 5. All right. So what is going to give the voltage? Voltage now is going to be equal to 5 multiplied by 16. This is the same thing by saying 5 cancel 5. So that we're going to have it to be what? 16. So the voltage is what? 16. So here we have a 16 volts. All right, so this is the end of this class of resistor in parallel and in series or in the same circuit. In our next class, we're going to look at internal resistor before we're now going to talk about the individual current passing through a different resistor. Bye bye. Don't forget to like this video. Let me know what you think on the comment section. Invite more of your friends. See you on the next video.